In 2005, the physicist Nima Arkani-Hamed made a prediction with a date on it. He had helped invent a theory that said our universe has extra dimensions, hidden ones, folded away where nobody can see them. Ask most theorists when their ideas will be tested, and they say decades or never. Arkani-Hamed named a year, 2008. When the world's largest machine switched on, he expected the first evidence to appear. The machine switched on. 27 kilometers of tunnel under the French-Swiss border. Billions of dollars. One of the most complex machines ever built. It ran for years. It found the Higgs boson. It found no extra dimensions. And here is the part that should be strange, and somehow isn't. Physicists did not abandon the idea. They still teach it. They still build on it. Many still think some version of it will turn out to be right, not because of experimental evidence. None has been found, but because several of our leading mathematical frameworks don't work without it. That's belief in something unseen, held by some of the most evidence-demanding people on Earth. 24 centuries earlier, a Greek philosopher described prisoners chained in a cave, watching shadows on a wall, convinced the shadows were everything there was. He was making the same claim, that what we see is only the surface, and the real structure is hidden. But there is one enormous difference between what Plato did with that idea and what physics did with it, and that difference is the most important thing in this video. Start with why anyone thought there were extra dimensions at all, because it did not begin as mysticism. It began as arithmetic. In 1921, a German mathematician named Theodor Kaluza was working on Einstein's equations for gravity. Einstein had written them for the 4 dimensions we know, 3 of space, 1 of time. Kaluza asked, what happens if you formulate the same framework in 5? And something extraordinary fell out. The extra piece of the equation, the part that had no business being there, contained equations equivalent to Maxwell's electromagnetism. Gravity and electromagnetism, the 2 forces known at the time, emerged together from one geometry, provided you allowed one more dimension of space. Einstein was intrigued enough to sit with it. He reportedly held the paper for nearly 2 years before recommending it for publication. There was, of course, an obvious problem. If there is a 5th dimension, where is it? In 1926, the Swedish physicist Oscar Klein gave the answer that everyone has used ever since. The dimension is there. It is simply rolled up so small that nothing can move through it noticeably. The standard image is a garden hose seen from far away. From a distance, it looks like a line. 1 dimension. Walk up close, and you find a 2nd dimension wrapped around it. A circle you could travel around if you were small enough. An ant on that hose has 2 directions available. You, watching from across the field, see only 1. Klein's proposal was that space itself is like that. At every point, dimensions curled so tight that no experiment has ever noticed them. The idea then slept for roughly 50 years. In the 1980s, a new candidate for quantum gravity revived it. Not as an option, but as a necessity. String theory, one of the leading attempts to unify gravity with quantum mechanics, does not merely permit extra dimensions, it demands them. Superstring theory is only consistent in 10 dimensions. Its extension, M theory, requires 11. Write it in 4, and it collapses. The extra dimensions are not decoration bolted onto the theory. They are load-bearing. And then, in 1998, came the idea that made all of this suddenly testable. And it is Arkani-Hamed's. Working with Savas Dimopoulos and Gia Diwali, he proposed a solution to one of the ugliest problems in physics. Gravity is absurdly weak, not slightly weak. A small magnet lifts a paperclip off the ground, beating the pull of the entire Earth on that paperclip. Gravity is weaker than the other forces by a factor with more than 30 zeros after it, and nobody knows why. Their answer was elegant, and it starts by flipping the question, what if gravity isn't weak at all? What if it is exactly as strong as the other forces? But unlike them, it leaks. What if gravity spreads into the extra dimensions, while everything else stays stuck in ours? We would only feel the fraction that stays behind. Gravity would seem feeble, not because it is, but because most of it is somewhere we can't go. And here is why that mattered so much. In the older picture, the extra dimensions were rolled up so small that testing them was hopeless. You would need energies no machine could ever reach, but in this version, they could be much larger, large enough that a sufficiently powerful collider might actually see the effects. A machine, in other words, like the one being built at that moment under the border between France and Switzerland. The Large Hadron Collider is among the most complex objects our species has ever constructed, a ring 27 kilometers around, colder inside than deep space. It accelerates protons to very nearly the speed of light and smashes them together hundreds of millions of times each second. And it knew what to look for. If gravity leaks into extra dimensions, then in a violent enough collision, some energy should leak out with it. Vanishing from the detectors, energy that goes in and never comes out. Physicists call this a missing energy signature, and it is exactly the kind of thing the LHC was designed to catch. There was a second, more dramatic possibility. If the extra dimensions were large enough, some models suggested colliding protons hard enough might briefly create microscopic black holes, evaporating almost instantly in a very particular pattern of particles. That speculative possibility is where the 2008 tabloid headlines came from about the collider destroying the world. It was discussed seriously within these models. But any such object would evaporate in a fraction of a second. There was never a danger. So they looked. For years, through 2 full runs and into a third, across multiple experiments, hundreds of searches, thousands of physicists. Nothing. No excess missing energy, no black hole signatures, no signal consistent with gravity leaking away into anywhere else. As of the most recent particle physics listings, every search has come back empty. And the limits have been pushed well past the energies the original proposal pointed to. Meanwhile, in far quieter laboratories, physicists have been testing gravity itself at tiny separations, checking whether its strength deviates from Newton's inverse square law at short range, which is what extra dimensions would cause. It doesn't. Down to below 1/10 of a millimeter, gravity behaves exactly as it should in 3 dimensions of space. Now, a precision that matters, because this is where these stories usually go wrong in both directions. This does not mean extra dimensions have been disproven. It means they have been constrained. If they exist, they are smaller or more subtle than the versions we knew how to test. The original Kaluza-Klein picture. Dimensions rolled up near the smallest scale physics can describe. Remains perfectly possible, and remains, with current technology, untestable. But something real did die. The specific, bold, testable version. The one Arkani-Hamed built. The one that made a prediction about a particular machine on a particular date. That version failed. It made a claim. The claim was checked, and the answer was no. And what I find genuinely admirable is what he has said about it since. Arkani-Hamed has described his own tendency to speculate, publicly and in print, as a personal weakness. Not false modesty, he said. A real one. And by 2008, he was reportedly telling a room of colleagues that string theory remains useful for studying quantum gravity, but is unlikely to tell us anything about particle physics. Note the precision of that. Not an abandonment, a narrowing of what he thinks it can deliver. This is a man who staked his reputation on an idea, watched the evidence refuse to arrive, and adjusted in the open, where everyone could see him do it. That is not a failure of physics. That is physics working. Which brings us back to the cave. In Book 7 of the Republic, Plato asks you to imagine prisoners chained since childhood facing a blank wall. Behind them burns a fire. Between the fire and the prisoners, figures carry objects along a walkway, and those objects cast shadows onto the wall the prisoners face. The prisoners have never seen anything else. They name the shadows. They become expert at predicting which shadow comes next. To them, the shadows are not a representation of reality. They are reality. The whole of it. Then one prisoner is freed. He turns around, sees the fire and the objects, and is dragged up out of the cave into the sunlight, into a world of solid things he had no idea existed, of which everything he had ever known was only a flat, flickering trace. Plato's claim is the one physics has been making all along. What the senses deliver is not the full structure. There is a fuller reality, and our ordinary access to it is partial by nature, not by accident. Notice how well the two pictures fit each other. Klein's dimensions are curled too small for us to enter, exactly as the world outside the cave is unavailable to a prisoner in chains. Both say the limitation is in the observer, not in the world. And now the difference, the one that actually matters. Ask what would have to happen for Plato to be wrong. Sit with that for a second, because there is no good answer. The forms are not the kind of thing an experiment could fail to find. No measurement counts against them. No instrument is relevant. The allegory is a description of the human condition, and it is beautiful, and it is completely safe. Because nothing could ever come back and say no. Now ask the same question of extra dimensions. The answer is precise. Build a collider. Accelerate protons to these energies. Look for missing energy in this range, for these decay signatures. If they aren't there, this version of the theory is wrong. And then they did it. They spent a decade and an extraordinary amount of money and the working lives of thousands of people building the thing that could tell them no. And it said no. That is the difference between the two traditions. Not that one is right and the other is wrong. Both are reaching for the same old human intuition. That the visible world is a surface and something fuller sits behind it. That intuition may well be correct. Physics has not abandoned it, and neither should we. The difference is that physics took the intuition and did the one thing philosophy never could. It made it answerable. It said, here is what would prove me wrong, and here is the machine that will check. So, where does that leave the belief? Honestly, roughly where it started, which is a stranger place than it sounds. Some of our best mathematical frameworks still require extra dimensions. The hierarchy problem is still unsolved. No broadly accepted replacement has emerged. And so many physicists continue to hold, with real conviction, a belief that their own best experiment has failed to support. They hold it the way you hold any unfinished thought, provisionally, with the label still on it that says unconfirmed. That label is not a weakness. It is the whole achievement. You can feel the small version of this yourself. Think of something you are fairly sure is true about your own life, about a person, about why something happened to you. Then ask what would have to occur for you to admit you were wrong. If you can answer that quickly and specifically, you are holding the belief the way a physicist holds extra dimensions. If nothing comes to mind, you are holding it the way a prisoner holds a shadow. Neither is shameful. Most of what any of us believes is the second kind, but only one of them can ever be corrected. Nothing here is finished. The searches continue at higher energies. Extra dimensions may yet turn up, or may be quietly abandoned in 20 years by people who found something better. Plato's cave will still be read in 2,000 years. and it will still be unfalsifiable, and it will still be true about something. What's actually here is smaller and more honest. The oldest intuition we have, that what we see is not all there is, was finally handed to people who insisted on being able to lose the argument. They built a machine to find out. They lost, and they told everyone. Ancient wisdom, quantum mystery, direct knowing. This is quantum gnosis.